you want the capacitor video to be, relative permittivity is equal to the absolute permittivity over permittivity of free space. These are the three connections between the permittivities we have. Relative permittivity is equal to absolute permittivity over permittivity of free space indoor. So that means your absolute permittivity is equal to the product of relative permittivity multiplied by the what? Permittivity of what? Of free space. So take note of that. Quite important. Alright, so now what are the dielectric for different substances? We have talked about the concept of dielectric before. So I'll give you the constant of dielectric for each substance. Now dielectric for vacuum is 1, while dielectric for air, okay, is 1.006. In case of question, you can just write that this for vacuum, that is 1. Alright, and for air, we have K to be what? Dielectric to be 1.006. So I've talked about permittivity, I've talked about dielectric. We said in the previous video that dielectric is actually a substance, alright, that separates the two plates we have. Okay, this 1.0006. This for vacuum, dielectric for vacuum, and this one is dielectric for what? Sorry, the first one is for air rather, for vacuum, and this for air. So that's what we have as the dielectric values. Then let's move to the superposition of forces. When you're talking about the concept of superposition principle, alright, now generally it means, alright, the total charge is equal to the sum of the individual charges. Alright, that's what it means. So we can say superposition of forces in what? In electrostatics is actually, it states that the total or the net charge is the algebraic sum of the individual charge, or in terms of the force, now we'll have the total or the net forces is this algebraic sum of the what? Individual force. So we are going to be having summation of F in superposition principle. Summation of force states that the total or the net force, alright, is the algebraic sum of the individual forces. So we have summation of F, that's the right thing to say. So we have F1 plus F2, alright, plus F3, alright, then to F infinity. This one we call this the idea of superposition of two or more forces. It states that the total or the net force, superposition of forces states that the total or the net force, alright, is the algebraic sum or the vector sum of the individual forces. So when you have your addition of forces together, you have them as a superposition. Okay, so let's move straight away and talk about other concepts like electric field intensity and electric potential, so and flux as well. So if you are to determine, so I've mentioned all of those things, how to determine your force, the value of K, your permittivities, your dielectric, and superposition of forces. So and I've talked about how to charge too, alright, the 3 methods we use in charging the material: charging by friction, charging by contact, and charging by induction. Alright, so now let's look at something right here. Now when you are talking about electric field intensity, alright, electric field intensity. Now in the previous video I gave 3 different values for electric field intensity, alright. I gave 3 formulas for that. Now the other name for electric field intensity is called electric field strength. Electric field intensity or electric field strength. So I gave 3 different formulas for that. The first formula of electric field intensity is given to be E is equal to V F by charge. That is the actual formula of electric field intensity. So electric field intensity is defined, alright, as force per unit charge. Alright, that is when in quantum, if you are doing physics 142 and you watch the quantum video, we said our E over 1 is equal to F over Q. So we have what? EQ is equal to F, or F is equal to what? EQ. That is force equal to the electric intensity multiplied by charge. So electric intensity is defined as the what? As the ratio of force per charge. The other supplementary formula or derivative we use, like electric intensity is equal to voltage over distance apart in parallel plate capacitor, and we have electric intensity is equal to charge density over the permittivity, alright, of free space. We can also use this supplement, but the real value is that, or the real definition of electric intensity or electric field strength is that E, alright, electric intensity is defined as the what? Ratio of what? The force per unit of charge, or you can just call it force per unit charge. So what is electric field intensity measured in? Electric intensity is measured in. Now, what's your force? Force is measured in Newton. So if you have F per charge, force per unit charge, force is measured in Newton, charge is measured in Coulomb. That means E should be measured in what? Newton per what? Newton per Coulomb. Alright, so that is how to go about that. So aside from that, the other things you should take note of when you are talking about charges is flux. All right, but before flux, I talk about flux. Flux. I want to talk about the electric potential. What's electric potential? Now, I've stated before that your electrical energy is equal to quantity of charge multiplied by potential. All right, I've stated this before. If you watch our electricity video, so what's going to happen if my W is equal to QV? All right, I'll make my value of potential is equal to formula. If I want to derive my potential or electric potential in electrostatics, so I have W is equal to QV. So I'll divide both sides by Q and by Q. So I have this and this. So I have W over what? Over Q is equal to V. All right, or V is equal to W over Q. Okay, if that's the case, what's going to happen is that we are going to be having our work done over charge that will give us the what? Electric potential. Okay, so electric intensity is defined as force per charge or force per unit charge, while electric potential is defined as the work done per unit charge. Okay, so if you want to find the real values now, let me show you something here. What is going to be the value of work done in electrostatics? Okay, so let us find it. Now my potential is work done over charge, so I'm going to be having my work done. What's work done in physics? Work done in physics is force multiplied by distance, so you have F times what? X. All right, and distance in this context is radius, so you have F. W is equal to F dot what? Change in R. So you have W is equal to. Now you know I have a value of F, so we can use this one to calculate for what? For force per charge is for electric field intensity. What is it? Force per charge is for electric field intensity. Force over Q. We have electric field intensity here. Force over Q is electric intensity. Then for electric potential is defined as the work done per charge. Then work done is defined as the what? Force multiplied by the what? Radius. Then we now impute the value of forces in each of those things. Your forces from what? Coulomb's law. Before we talk about flux. So if you want to impute the value of forces, all right, in each of those three terminologies or three factors, then let's see what we're going to be having as the final value. So for now, electric intensity is equal to what? Force over charge. All right, this electric intensity. What's electric potential? Is defined as this force per unit charge. Electric potential is defined as the work done per unit charge over Q. This is like equation 2. Then we said work done is equal to the what? Force multiplied by the what? The radius. That's equation what? Equation 3. Then we can now start something. So let's impute the value of force in each of those equations. What is your force? Your force is given to be what? KQ1, Q2 over what? Over R squared. So if you are imputing it one after the other, your electric intensity is now going to be force over charge. Then what do you have? You have E is equal to, what is your force? Force is now KQ1, Q2 over what? This over R squared, then over what? Over Q. Q will go with 1Q. Then what is left? E is equal to what? KQ1, Q2 over R squared. So this is the first equation of what? Of electric intensity. And you can also use this one to calculate for what? Electric intensity. KQ1, Q2 over R squared. Then once you are done, go and impute the value also. If you want to find work done, in that value, what is going to happen? So for a work done is equal to force times radius. So you have work done is equal to force times radius, force times changing R. Then W is equal to, what is your force? Your force is supposed to be given to be, according to electrostatics, KQ1, Q2 over R squared. So anywhere I see force, I'm going to be writing it as KQ1, Q2 over R squared, then multiplied by, your change in R here is multiplied by another R, alright? So what do I have? I have W is equal to KQ1, this work done in electrostatics, that's multiplied by R over R squared. What's going to happen? I'm going to cancel one R out, okay? One R cancel one R. Then I have what? KQ1, Q2 over what? Over R, because one R has taken one R in this place. So this becomes the value of what? Of work done in equation 2. This what is electric intensity in equation 2, and this work done in equation 2. If you are to determine work done, the value of K, which is 9.0 times 10 by minus 16, multiplied by the two charges. Then sometimes you can be given one charge and you have to integrate it in each of the what? Each of the equation, alright? So you can be given one charge, then you have to multiply the charge by itself. It depends on, so that is why you should understand your question and how to attempt it. So KQ1, Q2 by R is for work done. Then the potential now, let's go and find potential. What's going to be my potential? My potential is given to what? Work done over charge. Then I have what? V is equal to, what is value of work done? Work done was given to be what? We said W is equal to KQ1, Q2 over R. So I'm going to be having my work done to be KQ1, Q2 over R over another Q. So Q cancel 1Q. Then my electric potential is equal to what? KQ over what? Over R. This is the final value of what? Electric potential. So we have V is equal to E, electric intensity, which is force per charge, is equal to KQ1, Q2 over R squared. Alright. Then we have work done to be what? KQ1 Q2 over R. Our 4 is KQ